Hello and welcome to this Windows tutorial in how to get started with the ESP32. In this tutorial we're gonna build and debug an hello world example inside Visual Studio Code. I set up some goals and agenda here, and I'm gonna refer back to that as we go. Before we start, I just want to mention that you will need some sort of dev kit. I'm using a ESP32 Pico kit, and you will also need a debugger. In this example I will be explaining how to use the J-link from Segger, but this will basically work with any hardware debugger, and you will just... Okay, let's get started. Just type in docs and ESP-IDF on Google, and your first choice will be this ESP-IDF programming guide. If you're not new to the ESP32 and you already done this, then you can just skip ahead for the Visual Studio Code part if that is of your interest. Very important here is that you're going to use the CMake part of Get Started. This is because the Makefile build system will be deprecated very soon. And then go to step 1, set up toolchain, go for Windows, and then they actually made a tools installer for us Windows users. Just download that one to your computer. And that's it. We're done for step 1. Let's skip ahead for step 2. Next off is that we're actually gonna clone down the repository containing the ESP-IDF itself. Basically is that you're just gonna choose just any folder and clone it down to there. What they show here is that you actually use your user profile path that is similar to your home path if you're a Linux user, but very many people have a space inside of this path, and that will create some problems later on. So just know that avoid using spaces. For me, I'm just going to use in my root, I have something I call dev. I know your Linux users will feel a bit creepy about this. See dev, and then inside here I'm gonna make a ESP folder. I'm gonna cd into this folder, and then I'm gonna do a git clone, and then I'm simply gonna copy this one from this tutorial. The recursive part here is very important to have in your command, otherwise you won't get the sub-modules needed. Alright, that's it. Now you have your framework installed. Next part 3, will be to set up the environmental variables. One great thing, since we use the installer for the tools, is that it has already added the tools directly into the path. But we are going to need to set up our IDF path in order to get this working. So we open up a terminal, and we're just quickly going to check that our path is set up correctly. So I'm going to go echo percentage path percentage. And what we can see here is that we have a lot of program files /expressive /ESP-IDF tools, and etc. So it has already been set up by the installer. But if I go echo and do EDF path percentage, I can see that this one variable is empty. In order to set it up, I normally just type search. I start to type environment, and I find this edit system environment variables. Step inside here, environment variables, and I want to set a system variable. So I go new variable, variable name, EDF underscore path, and then for the value I'm just gonna browse directory. I did put mine in the C dev ESP, and we want to point to the ESP-IDF folder. You might put it elsewhere. Okay, and in order to get this one to update, I'm going to need to restart the terminal. I go echo %IDF underscore path %. Now it's set up. Step 4 and 5 is to check for the correct version of OpenOCD in Python. It's a really quick one. We will open up a terminal window, and we're going to check OpenOCD -- version. It's going to check. Yes, it is installed, and it was being installed by the IDF tools installer. Step number 5, check for correct version of Python. And we're just going to run a python // version, and we'll see that we have Python 2.7. Perfect. Well, there are also some Python packages that are required for our tools to work. In order to find these, install these packages, they actually made it really easy for us. We can go python m install, pip install, and go user, and then r, and then we can actually find $IDF, %IDF path %, and then go requirements.txt, and we'll actually open up a document, read it, and install our dependencies. Oh, I misspelled install. There we go. Alright, so I did run into a little bit of a side problem here. After installing the Python requirement, I wanted to try out one of the tools to make sure that it thinks that I comply with the requirements. And if I go idf.py build, I can see here that it tells me that the requirements are not satisfied, even though I know that they are. And this is probably because that I happen to have more than one Python installed. So I go add and remove programs. I already had it up, but I search for Python, and as you can see here, I have more than one version. I uninstall this older version. Okay, let me reopen the terminal, and then we go idf.py build, and it actually now says that the Python requirements are satisfied. So if you run into this problem, here's a fix for you. In step number 6, we're going to install the drivers for our J-link device, and if you don't have a J-link device and use something else, then you can just skip this part. I will use static USB driver installation tool to install my device. I just type static USB inside Google, and this is my first answer, my first hit. I will just download this program, and it runs from itself. I open it up, and here it is very important to choose options, list all devices, and you will find J-link here. I've already installed my driver, but if you haven't, it's very easy. You just press install driver right here. Alright, now we're getting to the more interesting part of this tutorial. We're going to open up Visual Studio Code, and we're going to do step number 7, install extension in Visual Studio Code. If you're new to Visual Studio Code, you have your extensions over here in the side, and there are 2 extensions that we're going to need. We're going to need this one, C++. If you don't have it here, of course you can search for it, C++, and it will come up, and then you just hit install, and there it is installed. And then we're going to need native debug. Search for it on its marketplace and you find it here and you press installed. That's it, you have your extensions installed. We're going to make a new project and we're going to use example code provided by the ESP-IDF. So we're going to open a folder, and wherever you installed your ESP-IDF, you need to find that search path now. I'll put mine in dev, ESP, ESP-IDF. From here, I go examples, I go get started, and then I choose hello world. I select this folder, and it shows up here on the sidebar. I can see here if I open up my hello world main.c that I don't have any IntelliSense, or more likely my IntelliSense can't find these include files, and this is something that we need to fix. It also created a .vscode folder, and that is used by vscode to set up your environment here. From here we will see that there's a small bulb up here in the corner, and we can right click that one, click that one, and we can go edit include path settings. This opens up this configurations tab for the C++ extension, and inside here you can find that we have a list of paths for the IntelliSense engine. From here we have our workspace folder, which is the hello world, where we are actually right now, but we also need to import our IDF include files. So we go $, curly brackets, we type env in order to import the Windows environmental variables, and we type IDF underscore path. From here we only want to import the components folder, and go slash and then **, and this ** creates a recursive search. From here we close the configurations tab and go back to our hello world main, and we can now see that some of the problems are solved. However, if you look into these ones that are still marked as an error, we can see that it can't find, for example, standard definition in standard io.h. Same thing here, some standard definition, standard bool. So basically it doesn't find our standard includes. So what we're going to do is we're going to go back to our bulb and we're going to try to fix this. And these are parts, the standard includes are part of the compiler. So where is our GCC, our compiler? When we run the EDF tools installer, it actually installed GCC for the ESP32, which actually is an Extensa microcontroller, and it's installed in program files, expressive, ESP-IDF tools, and then we go into binaries. And we can see here that here are all our binaries for our tools, and we find GCC just right here. So I'm just going to copy this path, and then we're going to go into compiler path, paste that in, and then we're going to go ahead and I'm a little bit lazy, so I'm just going to copy this thing, copy it back, and then .exe, let's change this one to default and see what happens, and we'll go back to our main.c, and we can see that all our problems is solved. You can also note that I have this sort of problem. You can't find a define inside the library, and I actually haven't found a solution for this yet, so you'll just have to live with this. But our IntelliSense will work now. So for example, let's say I would like to use the ADC. So I go include, I go drivers, because I happen to know that it's in drivers, and I go to adc.h, and now I've included this library. They should go away. Why aren't they going away? They are going away. Perfect. Alright, so next step here will be that we want to make this project buildable. So what we're going to do is that we're going to go into the vscode folder and go new file, and we're going to call a file tasks.json. Now this last part here is a very important part. We set group and we set this one to kind. I misspelled group, didn't I? Alright, there it is. Kind. I'm going to set this one to build, and then we're going to set is default, and then we're going to set true, and this is going to activate so we can go Control Shift B in order to build. So let's try this out. Let's go back to our main file and hit Control Shift B, and it opens up the terminal down here and it actually starts to build. That's great. Now we completed the steps that we can actually build our project inside Visual Studio Code. So for the next step, we want to set up so we can also debug inside this environment. So we're actually gonna, when you debug, it's actually two parts. It's the you need to open up an instance of OpenOCD in order to communicate with the hardware on the ESP, but we also want to start an extension of the GDB, which is the debugger. So I'm gonna add another task here actually. I prefer copy paste. So, and I will be using this one sort of a template. So I paste this one in. We're gonna call this task OpenOCD instead. Still want to open it in shell, run in the background, same working directory. The difference here is going to be the command. We're going to use OpenOCD. We're going to open a file. It's called interface /J-link CFG. And it won't matter where you are actually, because when you did the installation of the tools, it actually put up some paths for this file, so it will find them when you're invoking it like this. And for our purpose, we're going to use this file board ESP room 32 because it will work just fine with the development kit. But depending on what kind of hardware you are having, choose for yourself. All right. Just don't forget to remove this part here, the group. Otherwise, it will run this task when it builds as well. So we're not just gonna use this task by itself, but we're actually gonna make a launch command for this one. So we're gonna add a new file that's called launch.json, and we go curly brackets. Alright, let's try this one out here. I actually realized that I made some typos. It should be hello world, and of course in this part it should be a dot here instead. Alright, so let's hit the debug scene here, and there we go. See our flash and debug, and we hit that one, and it's going to be like a small warning telling us that it cannot be tracked. And this is because of a timeout in the background, because OpenOCD doesn't exit. Hit debug anyway, and there we are. We are right now debugging, and we can go step and everything. So that's it. That's how we set it up in order to build, flash, and debug. Gonna finalize this part by opening up a monitor. I've set up my PuTTY for COM9, and I have in serial, I have parity none, flow control none. Open it up, and here is our terminal, and I prefer to use PuTTY when I'm in Windows as my terminal, and this is basically what the main program does. It counts down to 10. So I'm gonna finish up this tutorial by putting in some side notes here. One thing is that you might want to set your debugger to a lower speed. I actually have mine set to 10 kilohertz instead of 20 kilohertz as it is per default. And you can change this one by going into your program files, expressive, tools, I think it's share, OpenOCD, scripts, and this is where you find the different boards and interface scripts. Since I use the room kit here, I have this one. Open it up, and you can set your clocking speed here, and I put mine down to 10 kilohertz instead of 20 kilohertz as per default. Another thing is that you would normally want to use, for example, the hello world as your as a template when you start a new project. This is because of the CMake system. So the CMake system is built around the CMake list.txt, and basically this just includes a path to that's inside IDF path here, and it names the project as well. So that's so basically when you use copy the hello world, you rename the project, and then you're done for your project, and then you start, and you will already have like sort of a main file here, and the hello world main, so you can rename this one as well. And it's also in the CMake lists where you add includes and etc. But that is out of scope for this tutorial for now. So thank you for listening, and I hope you are getting started with the ESP32.